All right, welcome everyone. Thank you for coming to this talk about data modeling with document databases. Who here has heard that document databases are schemaless? Raise your hand. Who here thinks that's a very scary thing? Raise their hand. Valid. With statements like this, or really tabloid headlines like this about document databases, we find that a lot of it is characterized in this way. So much that all we talk about is this schemaless thing that we can just do whatever we want with. There's field flexibility for all the documents that we are storing. And what data model, right? It's flexible, it's schemaless, you don't need it. But what I'm here to tell you today is that this is actually a thing that is necessary, and that's why I am here today to talk to you about it. While flexibility is great in theory, it's actually not that great in reality. In fact, reality dictates that all data has some sort of structure. That's the whole reason why it is valuable. The way that we work with it, the way that we interact with it in our applications, the way that we make sense of it, the way that we use it. The structure around the data that we're using is what makes it so necessary. And so for that very fact, we know that we need to adhere to this. And that's what I wanted to say was now I'm going to talk to you about the Developer's Guide to Data Modeling with 2 L's, because we're in the UK here, about document databases. The goals of this session are how to learn to create a data model in 3 specific phases. So we're going to learn a methodology that you can use that's an iterative methodology and that you can use it as your application evolves. Then we're going to apply that methodology. We'll see how it works by applying it to a casino floor analytics application. So I'm based in Las Vegas, so I know a thing or two about slot machines and where to go, where not to go. And so I figured this example will be a little bit different than some of the examples you may be used to. And finally, the last thing, which is also one of the most important things, is understanding what are we modeling for. So just because we know how to do it, it's very important to know what we are aiming for and how those decisions impact how we develop the rest of the data model. So it is absolutely possible to develop a data model for document databases, despite what you may have heard and despite all the tabloids you may have seen. And it's very, very necessary to have one. It's necessary because the data model that you create impacts your application's performance. The difference of this could be between something like this. This is kind of small, but it is a subreddit post about how MongoDB has absolutely staggering performance, and they probably had a data model that was well taken care of, well thought through, and evolved. And in the same subreddit, you have, I have such terrible issues with MongoDB. Performance is terrible. Why are we using this? And I can guarantee you that a big part of that is how the data model was created. So let's go through how to build a data model in 3 very particular phases. The first phase in building a data model with document databases is to make sense of your workload. So what does that mean? In this phase, it's very much a discovery phase. You're trying to make sense and gather everything there is that you could possibly know about the data that you're working with in your application. Out of this, you're going to get a batch of inputs, rather. And in these inputs, you'll want to list, qualify, and quantify the operations that are running within your application. What are the most frequent operations? What are the queries that you are running? What are the ones that you have but are not actually being run? What are those like? Is it posts, 2 posts per second? Are you reading something 1,000 times per second? Getting that kind of granular detail is very, very important for this particular input because you want to have a sense of what operations are running in your application. To help with that, you can also comb through your production logs and statistics, especially if you have them, and you would want to put that to good use. So not only from this would you get the other operations that you may be using, you may not be using, you can also measure how is your traffic like? What are your average scenarios? What are your spiky scenarios? What are some things that you may not anticipate but have logged in these particular logs? So those are also very, very good to have because you can have a baseline to measure from and then continue to measure against those as you continue to iterate your data model. From this, you can also get current and predicted scenarios. So let's say you're growing your application, or you open in another region, or you extend some features in your application. You can now also keep track of what is happening when those are deployed, as well as what predicted scenarios you might encounter. So similar to the spiky traffic or random quarter where you may have more traffic than anticipated. You'll want to keep track of those too. And what's always a good idea is to collaborate with a business domain expert. So as developers, we may be always in the weeds of the things. We're only very specifically focused on a particular feature or this particular story that we're implementing. And sometimes it's good to bring in somebody else to kind of help us remind us what other things we may be missing and look at the bigger picture of all the possible pieces of data that may be running through our application. So we take all of these inputs, everything that we could possibly have about how our application is using our data, we take that, and out of that, we should get a list of outputs. We should get the operations that we have. We should get queries that are most important, queries that are not being used, queries that are missing. Similarly, we'll get the data sizes that we have, some estimates, and also some real sizes based on the logs and things as we have discovered all of the data. We get the indexes, again, that we have, that we are missing, and we also get a lot of the assumptions that we are making about our application. So we take all of that information, because all of those pieces will definitely play a part in how we develop our data model, and we kind of feed that into the next phase, which is to map out and identify the relationships that we find as part of the data that we have made sense of. So in this phase, we do two things, and this can take a while, right? We do this as we see necessary. The first part of this is to quantify and identify relationships. So who here has seen this notation, and who knows of these relationships? One-to-one, one-to-many, many-to-many? Okay. It's very similar in document databases. So if you come from a relational database background, this similar Crowfoot notation, this applies in document databases too. We have one-to-one relationships, we have one-to-many, and we have many-to-many. And one thing that we did find when working with document databases, and as the amount of data that we were able to capture grew, we actually found we needed to add another type of relationship, something called one-to-zillions. So with all the data that we are capturing, we found that this is another relationship that was needed to capture and modify how we describe our data. And with that, how we would notate this particular relationship is you would list the minimum, which is usually 0 or 1. We list the likely amount. So this is where having that information from the first phase is very helpful, because you can have an estimate or an average scenario. And then you have the maximum amount of this particular relationship. This could go way, way into the millions, the hundreds of millions, thinking about IoT sensor data, or just anything that has a really, really high scale that could apply to this particular relationship. So once you've found all of those relationships and you find the most important ones and you designate to what type of relationship they are, the next thing to decide is, do you link it or do you embed it? And how many people are going, wait, what's linking and what's embedding? Does that sound okay? Cool. This is going to be useful for some of you. So linking and embedding is very, very easy to understand, because one of it you most likely understand already if you come from a relational background. So linking, here we have a simple document, and I might zoom in because I know that when I checked from the back, it was quite hard to read. So we have a very, very simple document here, a casino document, and it lists the names, the nicknames of this particular casino, the year it opened, etc. Some information about that. Linking just says we have some other information that is stored in a different document, in this case the owner, and we are getting that information very similarly to a foreign key relationship. So we use some sort of identifier to help us see what information is related to this particular document. And so here we have owner with an ID of 3, and that essentially is linking. It's very, very similar, almost exactly the same as foreign key relationships. Embedding, on the other hand, sounds exactly like what embedding sounds like. So instead of having this in two separate places, we will probably take the most necessary information, or the information that we find we are always querying together, and we take that information, in this case the name, the headquarters, and when it was founded, and we embed it into the parent document. So obviously in this particular scenario, you'll know that because we embed it here, that doesn't necessarily mean we get rid of the other document where the owner information is. So with embedding, there will come some data duplication. But the benefit of this is that when you embed things, you usually want to do that when you're working with document databases, because one of the core things to remember about working with document databases is that data that is accessed together should stay together. And so if we find that we are querying for this casino information and find that we always need that owner information, it's most likely a good idea to just embed that. So depending on the type of relationship that we have in our application, we'll find that there are some pros and cons to whether or not we decide to link or to embed. So if we go through and look at the first one, if we embed things in parent documents, for one-to-one and one-to-many relationships, the benefit of this is that we'll have a single read, right? We're taking the information that we need, that we're going to most likely access at the same time, we embed it in the parent document, and we'll have ideally a single read. And that also lends itself to having less complicated joins or less queries in what we're doing. And in a many-to-many relationship, we will also again have a single read, but as I mentioned, you'll have some duplication of information. In the document linked in parent document, oh, I have a laser pointer. Okay. In the document linked in parent document, the other hand here is if you do have linking, you will have smaller reads and you will have many reads. So it's important to take into account what is more important for your application. Do you need quicker performance, or can you get by with multiple reads but smaller reads because you have less in memory? So that's something to take into consideration when you are deciding whether to embed or to link. And then one other thing that's actually not part of this chart is if you have that 1 to zillions type of relationship, you'll most likely want to link. This is where linking is actually more encouraged. We actually discourage embedding just because of the vast amount of data that you're working with. So we've made sense of our workload. We know what kind of data we're working with. We know what kind of operations we're running. And then we've found out what the most important relationships are, the structure of our data, how it's being used in our application. And bonus, you actually have a data model at the end of this phase. So one caveat here is that this next pattern, or this next phase here of applying design patterns, you may not actually have to go through this phase. What we encourage is as you go through phase 1 and you go through phase 2 and you apply that data model to your application, you don't necessarily apply phase 3 unless you start seeing the need for it. The need for it means you start witnessing some performance issues, or you find a degradation in performance up to a specific threshold that your application cannot tolerate. When you start finding these types of scenarios, that's when you want to apply design patterns. So you don't need to apply design patterns at the beginning, but we'll talk more about when you decide when to actually do this when we talk about what you're modeling for. So let's say we do go through and apply design patterns. Let's go through what those are. So what is a design pattern? In this particular case, it's a reusable solution to a commonly recurring problem, right? We have patterns in computer science, we have patterns when we are writing code, and it's very similar here when we are doing data modeling. So in this particular case, it applies to the data structuring model that solves common use cases. So depending on the type of application that we're creating, or depending on the problem that we are solving, there is a way to model the data that actually accounts for that specific problem. So what design patterns are available? I'll have a caveat here. There are about 12 design patterns, and that could be its own talk. I will go through about a few today. The ones that we're going to go through are example, but just keep in mind that there are others that account for other scenarios. So we'll start with the polymorphic pattern. Who here has heard of the word polymorphic? Good. So you already know this pattern, which is great. So polymorphic is the basis for most of the design patterns. And what this means is that because documents are flexible and because they don't have to look the same in every single document, that's all that polymorphic really means. The added bit to this is that they can look different and exist in the same collection. So let's see an example here. So let's say as part of this application, or a different application rather, sports betting, or something that keeps track of athletes. And when you look at the vast array of athletes, there are different types of athletes, and different type of athletes warrant keeping different types of fields or information about them. So here we have the late, great Kobe Bryant, who is a star basketball player, and we also have Serena Williams here. And the similar information that we're keeping with these athletes are the sport that they're playing, their name, and their career earnings. What's different is obviously depending on the sport that they played. So for Kobe Bryant, we're also having NBA championships and if they're in the Hall of Fame. Whereas with Serena Williams, we're keeping track of the event that she is playing. Now, because Serena Williams plays tennis, there are also different events in tennis, right? There could be things like this, where she plays in both singles and in doubles type events. So polymorphic just means that this particular type of document, though very different than Kobe Bryant's document, can exist in the same collection of athletes. And that's just important to remember for the rest of the design patterns that we have here, that two different types of documents can exist within a single collection. The next pattern I want to talk to you about is something called the attribute pattern. So this one is useful for problems where if you have a really large amount of documents or big documents, but you're only querying on a very specific subset of fields. So let's say in this particular example that we want to search for movies based on release date. And you'll know that this is a problem because movies don't get released on the same day. They get released on different dates in different countries around the world. And so if we modeled our data in this way, if we had a top-level field for every release date, that causes a problem, right? It poses a problem because we know that we're searching for it. That means we're going to have an index for every single top-level field that we have here. Instead, we can apply the attribute pattern to this particular example and do something like this. We take the attribute that we know that we're going to search on and we add it into an array. We make it a key value pair that we know that we're going to be searching on. So instead of having a top-level field for every single country, which can grow and grow and grow, we post it in this way. And what this does is now our indexes become more simple. In fact, we only have to do a single one, very directly towards the location and date attribute. So the pros of this is that obviously fewer indexes are needed and queries become much simpler to write because we don't have to go through and start filtering on all the particular release date fields if they were at a top level. Finally, there's something called the document versioning pattern, and this is very, very useful because this is something that can be applied even to existing systems today. This is very, very useful when you need to have a current state of something, but you also need to keep a history of any revisions that have been made to your data. The other caveat to this is that usually those changes don't occur that often, but it's still important to keep track of those changes. So a really, really good example, unfortunately somewhat boring example, is insurance. So when you get insurance, most people get a standard policy rider. You have some basic things that are covered, and that's how you are stored in a potential an application that keeps track of all the people that get insurance. And so for this case, we have Bilbo Baggins here, and when they first received their insurance, the only thing that he really had to insure was the elven sword. So at the beginning of this, we would store Bilbo into our collection of current policies, and we will store him in there just like this. We have an identifier, the name, and the key here is this particular identifier, the revision. So now what happens is, let's say Bilbo has something else to insure. He has a new one ring that he now wants to absolutely add to his insurance policy. What will happen now is we'll create a new document in a separate collection. This could be called the policy revisions collection. This is the history of changes that we're keeping track of. And we will add that old state. So now we will add what his old insurance looked like. And now we'll have the current state here where the only change is he added something to the items insured. And the versioning is kept by this revision identifier. So keeping it in this way allows us to always have the current state available and always allows us to have a history of all of the particular insurance states that Bilbo has had. The cons of this particular pattern, though, is that it does double the number of rights. So every time you do make a change to the current policy of somebody, you have to create a new document to keep track of whatever the old state was. And the queries also need to target the right collection. So depending on how you separate, how you're keeping track of all of the changes, you need to make sure that you are targeting whatever is the place that you are holding all of the current states in. The pros to this, though, is that, like I said, it's very easy to implement. All you really need to add is some sort of revision identifier or any type of identifier that tells you this is the most recent one. And there's no performance impact on queries on the latest revision, assuming you target the right one. And that's just 3 out of the other types of design patterns that are available here. So the ones that we went through are the polymorphic, which you'll see here. The top use cases where you would see this and you would benefit most from are catalog type of applications, content management, and mobile applications. We talked about the attribute pattern, which is similar, along with single view type of applications. And we also talked about the document versioning, which is also a good use case for personalization. So if you're interested, there's actually a really, really good blog series from Ken Alger, who wrote about all of the patterns, and I will tweet that out later to you if you want to read more about them. And that's it. At the end of this 3 phases, you have a data model that you should be happy with and should be working for the application that you have. What's important to note is that once you reach this end, even if you get to the point where you go through the data phases or the 3rd phase and apply design patterns, you can continue to go through this as your application evolves. So like I said, if you start to see performance issues or you find that your application is growing and has other features, then you can go through this process again. And that's kind of encouraged. You want to go through this methodology as many times as necessary so that you're happy with the data model that you have and it fits with the application that you are building. So we've seen how, right? What is the methodology? Now let's go through an actual example. So hopefully it will stick a little bit more. The first phase is to make sense of our workload, right? So for casino floor analytics, who here has been to Las Vegas? Raise your hand. Okay. Who here knows that it's more than casinos and strip clubs and buffets and there's 1 hand in the, okay, 2 hands in the back. That's good. Well, if you're ever in Las Vegas, I would love to show you the other side of Las Vegas, where it's actually a nice place to live. But a casino looks like this. It's very dark on purpose. You don't know what time it is. They want you to be disillusioned, not know what time it is. You have your table games. You have your slot machines. It's a maze, and it's made that way because they want you to stay there and give all the money away and give it to the house, right? Gamble it all away. Now for our casino analytics application, we will focus on particularly the slot machines. So we want to keep track of how our slot machines are doing in our casinos. So with this comes all kinds of pieces of information with slot machines. There's the win chance rate, there's jackpots that we have to keep track of, there's bonus structures that may change either because the Nevada Gaming Commission changes the limits on them or the casino tweaks them a little bit. There's all types of things that we need to take into account in this casino floor analytics application. And so we'll start with that first phase, right? We have to make a sense of our workload. So after we go through all of those inputs that we may have, we find that these are the most important or the most commonly recurring operations. Maybe we have some query that tells us the total player game time. That is a write that occurs, and we can get this because every time a player inserts their card into a slot machine, we can tap into that. We can tap into whenever they insert the card and remove the card, and we have the total player time there. We have a few reads here. We have the win chance rate, which again, some is set by the Nevada Gaming Commission. We have anomalies in win rates, which not only on table games, but I don't know if you've ever seen any documentaries on how casinos are run. There's a million cameras, there's heat sensors, there's all kinds of things to detect if somebody is cheating or not, and if they had a legitimate win at any of the games in the casino, because that's very important. We have the top slot machines that are played. So again, not only we can tap into how long people are playing, how many times do they go back to that particular slot machine? How many times has a jackpot been won on a particular slot machine? There's so many different pieces of information that can be captured through these actions that occur within a casino. And finally, there is a jackpot increases query that we have, which is another write. So if you've ever been to a casino, there are some groups of slot machines that usually they're in a circle or they're in a row, but they all contribute to the same jackpot. And you'll see the jackpot continues to increase and increase and increase. And as people play and nobody wins, that jackpot continues to increase. When somebody wins that jackpot, it resets and goes and continues to increase as more people play. Sometimes this group of slot machines is just in a single casino. Other times there's a whole network where actually multiple groups of slot machines all combine into a single jackpot that could span across multiple casinos. So that is what is taken into account here for these jackpot increases. So those are the most important operations we have found for our particular application. Now the next phase is to map out and identify the relationships that we see within these particular pieces of data. We find that we actually have quite a few one-to-many relationships, right? For slots and casinos, that's actually one-to-one because every physical slot machine can only ever exist in a single casino. It can only physically ever be there one single time, can't be in two places at once. And then the rest of our relationships, we find that the most important entities we have are the slots, right? We have the casinos, we have the players, and then the different types of games and bonuses that we have. And finally, we will be applying a few design patterns to our particular data model. And what our data model could look like is something like this. So I'm going to zoom in because I know it's a little hard to read. So out of the entities that we have, we find that we have a slot entity that we need to keep track of some data here for, like the manufacturer, the location, serial number, etc. We have the jackpots, we have casinos, and we have our players. And these are the most key entities that we need for our particular application. We'll start with the first decision, which is deciding to embed these particular pieces of information. So for slots, we have opted to embed bonuses because, and you'll see here it's slightly attribute pattern here, which I'm already getting ahead of myself, but we've embedded the bonuses because as we query for our slot machines, we find that we always look up the bonuses as well. For jackpots, we want to know the participating slot machines that are contributing to that particular jackpot, so we've embedded that information. For casinos, we usually query them trying to look for what the top slots are, so that piece is also embedded into our casinos document. And then we have opted to embed both the membership and the contact information for our players, because sometimes they can have multiple memberships at multiple casinos, and their contact information is usually always needed anytime we need to query for a player. So those are the embedded decisions that we have made as part of our data model. For our document versioning pattern, we have applied that here for both the slots and for the players. Because as their information changes, let's say their contact information changes or their state changes, maybe they were a high roller, they had one really bad weekend in Las Vegas and they're no longer a high roller, that kind of change is something that we want to keep track of. Similarly to the slots, we've opted to use the document versioning pattern here because the slots configuration doesn't change that often, but we do want to keep track of when they are changed. Lately, they have been, I don't even think they have any mechanical slot machines anymore. They're all digital now, but all the little wheels that are turning, these are all digital. There's almost no, even in the old local Las Vegas, old or downtown Las Vegas, those used to be the last refuge for the legit old school slot machines where they were mechanical, and those are gone. And so keeping track of that, maybe with maintenance logs and things like that, we do want to keep track of what the life cycle of a particular slot machine was. For the attribute pattern, I already mentioned that. So in particular for slot machines, the bonuses that we have, when we do query and analyze which slot machines are performing the best, we usually want to take a look at what the multiplier chance is and see if that has an influence on which ones are doing better, as well as the location of that particular slot machine. And then we have our trusty polymorphic pattern at play here, right? So most slot machine documents will look like this. They'll have the identifier, the manufacturer, where it's currently located, serial number, etc. But depending on the type of slot machine that it is, it could look like this. This one would relate to a slot machine. If you've ever seen, there are slot machines where you can choose a particular type of game on it, and there could be up to 16 games on it. That's Jacks or Better or Texas Hold'em, all of those different types of games on a single physical machine. So depending on the type of game that you are playing, that changes the configuration of the slot machine, and that's how that particular slot machine information could look like. That document could look like this. Or, like I alluded to, with an older slot machine, maybe we want to keep track of its decommission date. It's no longer in service. We want to have a history of the log, maintenance log that it has gone through, especially for the mechanical parts. So again, this kind of document can exist within the slots collection, even though it is slightly different and more configured for a very particular kind of slot machine. And that is how you would apply an example of how you would apply these phases to a particular casino floor analytics application. So now the next question you should be asking yourself is, this is great, Adrienne. Now I know how to develop a data model. Now I know what to do and how to do it. But the next question is, what do we model for? And it always comes down to the two things that are competing: simplicity or performance. So when you're deciding between the two, there are obviously some things that you should take into consideration. These are general guidelines of what you would want to choose, but they are pretty good guidelines when you're first starting out and starting to develop your data model. So if you want to go for simplicity, you want to take a look at the size of your project and the size of your team. Is it a very small project? Is it an early stage? Is it an MVP? Are you the only one that's going to be maintaining this project and this data model? What are your data sizes like? Are you using shared or hosted resources? And what is your scale like? Do you only have a few requests every week? Or do you only have a low read and write rate? These are the types of things that would kind of push you to say, I don't really need a complex data model. This one, this simple one, is actually going to serve me just fine. Now, if you find that you need to model for performance because you're way past that, you are on multiple regions, you're a distributed team, maybe you already have sharded clusters that you're working with, and your scale is way more into the thousands per second, and you need to give the same experience to all of the people who are using your application, then yes, performance is something you probably want to take a look at and focus on when you are developing your data model. If you take anything away from this, I encourage you to err on the side of simplicity. Because again, because the methodology is iterative, you can continue to work on it and go through it and evolve it along with your application. And it's always easier to build on top of a simpler data model, one that you can understand, and one that can make use of and have the design patterns that you apply be beneficial to it, always be better. So always err on the side of simplicity. Start out with the simplest data model because you can always build on top of it afterward. When you focus on simplicity, what you will focus on are the most frequent operations. So instead of listing every single thing out and quantifying every single piece of information you have, focus on the most frequent one. You embed most things because, again, data that should be accessed together stays together, and that makes for a more simple data model because you have the data in the parent documents already. And if it makes sense, maybe you use one pattern. Maybe you have a very specific scenario that could account for one of the patterns. If you focus on performance, that's where you go full pedal to the metal, right? You want to list every operation out. You want to quantify it. You want to get to the rate of, I know I am doing 2 posts per second, or I am fetching, all tweets at this rate. You want to be able to have that granular breakdown of the data that you are doing, and you want to have a good grasp on all of the operations that are happening with your application. You want to embed and link as necessary, and you will be needing linking because if you are running at the scale that warrants data modeling for performance, you can't get by with just embedding. You're going to need to link a lot of things as well. And you'll also need to use as many patterns as necessary. But again, go through the first 2 phases, even if you're modeling for performance. And if you find that you are still struggling or you're not attaining the level of performance that you want, then start thinking about applying design patterns. You can go through and apply design patterns right away, but that goes against what we were encouraging, which is to err on the side of simplicity. So start out small, start out simple, only apply as necessary, and it will be better in the long run for you and for your data model. And if you want both, because everybody wants everything in life, then you'll want to mix these kind of guidelines, right? So you will do most operations, you will quantify most ops, and instead of being so granular or only focusing on the top, come in the middle, right? Find the top 5, the top 10 most important operations, and maybe have that detail for just the top 10. You'll want to embed and link still because for performance especially, linking is going to be absolutely necessary if you're modeling for performance. And then again, you'll meet in the middle. You'll use a few patterns. You'll absolutely be able to take advantage of document versioning pattern, the polymorphic pattern. One that I didn't get through is the schema versioning pattern, which sounds exactly like it says. So if you do change your schema often, it's very similar to keep track of what schema type you are using. That's also helpful when you're needing to have backwards compatibility. All of those are absolutely going to be something you will be able to use and could be one of the 3 patterns that you are using. And then only apply the more complicated ones as performance issues occur. And that's pretty much it. That's how you build a data model. I want to thank you for listening to me. If you have any questions, I will be around. Feel free to come up here or find me. I'll be around in the conference. But thank you so much.